Exactly.
Yeah.
So we're going to go on and get started on the note sheet today. So the note sheet we're going over today, we're not going to go over, guys, we're not going to go over every single problem.
We're only going over 2, right? That's what you said.
Tomorrow.
Oh, damn, we'll be gone.
Yes. Now, the steps that we're doing today and the way we're going to solve these today is very similar to what we did yesterday. The main difference is these are going to have extraneous solutions. That's the only main difference between what we did yesterday and what we did today, is that some of the solutions that we will get for these problems won't work in the original problems. So we're going to have to go back and check to make sure that the answers do work and to determine which ones don't. Now, when we solve problems like these here, so this one here, x is equal to the square root of x plus 6, our first main step still holds true, that we need to get the radical by itself. Is the radical by itself? Well, yes. Since the radical is already by itself, we can go on and put both sides to the nth power. In this case here, we're just putting both sides to the second power. Now for the left side, when we take x squared, well, we get x squared is equal to. Now we have to square the other side, so we're squaring the square root of x plus 6. Well, the square root and square will cancel out, leaving us with x plus 6. So it's not any real different than what we did yesterday at this point. The only main difference is now that we do have an x squared, we have a quadratic term. So in order to solve at this point, we need to get everything on the same side and get this thing equal to 0. Well, at this point here, we can subtract x from both sides. And if we subtract x from both sides, we're going to get x squared minus x is equal to 6, because our x minus x would be 0. Well, it's still not equal to 0, so we can go on and subtract 6 from both sides, which will tell us that x squared minus x minus 6 is equal to 0. Any questions on any of this here? Okay. Well, now the next thing we need to do is just solve this quadratic equation. Now, because there's not a term in front of x squared, we know that, or the expected solutions, if we do have real solutions, should be whole numbers. The only way that we'll get rational or fractional answers is if there's a term in front of x squared. So that means we could graph this and see what the solutions are. We can plug it into the graphing calculator and see where it crosses the x-axis to find the solutions. We can also factor this with our two sets of parentheses. And if we factor this, since the 6 is negative, our signs are going to be opposite. One is going to be positive and one is going to be negative. Then we look at the factors of x squared, which are going to be x and x, because that's the only set of factors for x squared. Then we would look at the factors of 6. Well, the factors of 6 that we want are 2 and 3. And the 2 would be positive and the 3 would be negative. Now, because we do have two things multiplied together to equal 0, one of them must be 0. So we're saying that either x plus 2 is equal to 0 or x minus 3 is equal to 0. So at this point here, we would subtract 2 from both sides, telling us x is equal to negative 2. And here we would add 3 to both sides, telling us x is equal to 3. So that would give us our two solutions. Now we do need to check to make sure that they work in the original equation. Any questions on this here before we check? So what we found out was that x is equal to -2 or 3. If we check -2 first, so -2 is equal to the square root of -2 plus 6. Now if we wanted to at this point, we could type each side into the calculator to check. Well, -2 is just going to stay -2. We don't really have to type anything in for it. The main thing that we would type into the calculator is the square root of -2 plus 6 to see what we get. Well, if we worked out by hand exactly, it would be 2, because -2 plus 6 is 4, and the square root of 4 is 2. Well, -2 is not equal to 2. So that tells us that -2 is not a solution. It doesn't work back in the original problem. We can check 3. 3 is equal to the square root of 3 plus 6. 3 plus 6 is 9, and the square root of 9 is 3. So that means 3 is our solution. And a lot of this here with extraneous solution, where this comes up and why this gives us answers that don't work, is revolving around the fact that we have this variable outside the radical that's being squared. It's causing these extraneous solutions to appear. Any questions on this here? Besides having a quadratic, is this any really different than what we did yesterday? Not too much, it's the same thing. We just have some different terms. Let's go on and look at another one like this here, and then we'll kind of move on to something that looks a little bit different. Now again, just like with the first one, we want to get the radical by itself. Is the radical by itself? Well, yeah, we just have that square root on one side. Nothing else is added or subtracted or multiplied by it. So we can move on to putting both sides to the nth power. So in this case here, we're putting both sides to the second power. And for us here, x squared is going to be, well, x squared. Because that's what we get when we multiply or apply the second power to x. We get x squared. Now when we square the square root of 20 minus x, we get 20 minus x. Because the square root and square will cancel each other out. They will simplify out, leaving us with 20 minus x. Any questions on this so far? Now we need to get this equal to 0. Because of the x squared term, whenever we have a variable with a power greater than 1, so 2, 3, or higher, we need this thing equal to 0. So what we can do is, first off, add x to both sides, which will tell us that x squared plus x is equal to 20. Since it's still not equal to 0, the next thing we could do is subtract 20 from both sides, telling us that x squared plus x minus 20 is equal to 0. We got it equal to 0. Any questions on this here? Now, most likely we're going to get whole number solutions, so we could factor this or graph it. We know that we most likely won't get fractions because the number in front of x squared is 1. It's been a while, but our rational zeros theorem is the factors of the constant term over the factors of the leading coefficient. It's all going to be over 1. So if we do have rational fractions, factors, or solutions, rational solutions, they're all going to be whole numbers. So let's go on and graph this. Well, it wants me to. And all we got to do to graph it is go into y equals. Okay. And say x squared plus x minus 20. And hit graph. Because we're trying to see where it's going to cross the x-axis. We do see that it crosses in two different places, yes? Now those don't look like whole numbers, but I have a feeling that if we look at the table, we do see that x, when x is 4, the value of y is, so that's one solution, yes? Well, if we go up, at -5, it is also 0. So what that tells us for this here, for this quadratic, our solution is that x is equal to -5, 4. Those are the two values of x that will make this function equal 0, yes? Because when x is -5 or 4, the value of y corresponding to it is 0. We're trying to see what value of x will make this function be 0. So we found 2. Now all we need to do is plug it back in and check to make sure that they both work. Any questions on this here before we check? I have a feeling y'all have already figured out which one doesn't work. Is if we check -5, of -5, 20 minus -5 is going to be 25. And it's going to tell us that -5 is equal to +5. That doesn't work. And one kind of giveaway for this here is that the numbers that come out of a radical can't be negative. If we check 4, 4 is equal to the square root. 20 minus 4. Square root of 20 minus 4 is square root of 16, which tells us 4 is equal to 4. So -5 does not work, but 4 does. So for this here, the actual answer would be 4, not -5, because when we check it, we see that we don't get the same thing for when we plug in -5, but we do with 4. Yes, sir? Any questions on any of this here? Okay. Any other questions on types like this here? Or do we feel comfortable with these? For the most part, yes. It's not any too different than what we did yesterday. It's just now we have an x squared instead of just a linear terms, and we do have a possible extraneous solution, a solution that won't work in the original problem. All right. We're going to look at this one next. So we don't have a variable outside of the radical, so that's kind of nice. But our first main step still remains the same. We need to get the radical by its. So what can we do first? We can. Exactly, we can minus 13 from both sides. Apparently I'm going to write in a highlighter. And if I subtract 13 from both sides, 13 minus 13 is going to give us 0. Just leaving the square root of 5 in is equal to -10. What can we do next? Exactly, we can square both sides. Put both sides to the nth power. Now on the left-hand side, we have the square root of 5n squared. And as we've seen over the past few days, those square roots and squares will cancel out because a square root is the same as the 1/2 power. 1/2 times 2 is 1. So that radical will simplify out, leaving us with 5n is equal to negative 10 squared is 100. The negative times a negative would be positive, and 10 times 10 is 100. And last but not least, what do we need to do? We need to divide both sides by 5, telling us that n is equal to 20. Any questions on this here? I think we might need to check this. I'm just because, that header, identify extraneous solutions, might need to plug it back in. Let's just check and see. So we're saying that 13 plus the square root of 5 times 20 is equal to 3, yes? Now 5 times 20 is 100. Now the square root of 100 is 10. 13 plus 10 is? Now is 23 equal to 3? No. So will n being 20 work? No. So that solution doesn't work. Did we have any other solutions? No. So this here is no solution. There is no solution for this one here. All right. I'm going to back up a step on this one and go all the way back to here. Now we said, kind of in some of the previous ones, I can't take the square root of a number or an expression and get a negative number, yes? Isn't that what I have right here? Because I know if I square something, if I squared, say -4, squared is 16, because we know -4 times -4 is 16, yes? But that's if we're squaring something. But if I'm taking the square root of a number or an even root of a value, what comes out, if it's already positive, is going to be positive. We can't get a negative number out of this here unless we are applying an even root. If we apply an even root, we can get the plus or minus. Here, we're already starting out as an even root. We can't have this be negative. The number that comes out of a radical, when it's not applied to it, when it's not talking about something being squared, can't be negative. So this doesn't work. Let's look at this one here. Apparently it's really enjoying using a highlighter. So our first step is to get the radical by itself, yes? So what would we do? Subtract 10 from both sides. And if we subtract 10 from both sides, we get that the square root of 3m is equal to -9. What can we do next? We can square it, yes? But also, what do we know about a radical? It can't be negative, yes? So is there any way we can actually get a solution from this here? No. So this is, we don't have to solve it. Because the only way that this would work is whatever value came out of the square root of 3m was negative to simplify or to reduce 10 down to 1. There's no way that this is going to work. So really, if we're solving these radicals and we get an even root by itself, there's nothing left in front being multiplied by the radical, and we aren't adding or subtracting anything from it. It's already by itself, and it's equal to a negative number. We're done. There's no way that it's going to work. This is a no solution. Questions on these here? All right. This here is the last type that we're going to look at today. And the reason that this one's different than what we've done is this one here does have a variable outside of the radical and a number with it. A variable and a number with it. And whenever we solve these here, we're not doing anything different than we've done. The steps that we did yesterday and the steps that we've done so far today are still going to hold true. Because again, we want that radical by itself. Is this radical by itself? Well, yes. Okay. Now we can put both sides to the nth power. So here, we're going to put both sides to the what power? Second power. We're going to apply the second power to both sides. Now for us here, the right-hand side's kind of nice because the radical and the square will cancel, leaving us with 7p plus 15. Now, unfortunately, that doesn't work the same way with the p minus 1 or p plus 1 because we do have more than one term. And really what this is telling us is that we have p plus 1 times p plus 1. We're multiplying it by itself. So we're going to have to distribute this. We're going to have to work this out. Any questions on this so far? Now, when we do this distributive property, we'll multiply through by p first. So p times p is p squared. P times 1 is going to be plus p. Do the same thing with 1. 1 times p is going to be plus p. And lastly, 1 times 1 is 1. Now at this point here, we can combine like terms, which will tell us that we have p squared plus 2p plus 1 is equal to 7p plus 15. Really the only difference between doing this here and when we solved higher degree polynomials or quadratics is we have radicals to start with. Not too much different. Any questions on this so far? Well, we need to get this equal to 0. So we can subtract 7p from both sides, yes? What else are we going to have to subtract? 15, yes? We can do it in one step. The only reason we don't normally do it in one step is because that's a lot going on for some. And we can sometimes get the signs mixed up or combine the like terms incorrectly. But there's nothing that says that we can't do it in one step. But when we subtract 7p from both sides and 15, we should get p squared minus 5p minus 14. Any questions on this here? Now we need to solve this here. Do we want to graph it or factor it? Which way do we want to do? can factor this here. Now, since the 14 is negative, our signs are opposite. One's going to be positive, one is going to be negative. The only factors of p squared are p and p. And the factors of 14, 1 and 14, 2 and 7. And exactly, we're going to want 2 and 7. And the one that we want to be positive is, and the 7 would be negative. At this point here, we can set both of these equal to 0 and solve for the value of p. And for the first one, we would subtract 2 from both sides, telling us p is equal to negative 2. And for the second one, we would add 7 to both sides, telling us p is equal to 7. And most likely, which one do we think is not going to work? The negative 2. Most likely it's not going to work. But it's still good to check these two here, back in the original problem. P equals negative 2 and 7. So if we say negative 2 plus 1 is equal to the square root of 7 times negative 2 plus 15. Well, negative 2 plus 1 is negative 1. Now at this point here, when checking, we could type this onto the calculator. You don't have to step this out one step at a time. And we could plug it in. If we did take it one step at a time, 7 times negative 2 is going to be negative 14. Negative 14 plus 15 is 1. And the square root of 1 would give us 1. Well, as we expected, that did not work, so negative 2 is not our solution. We can do the same thing with 7. Well, 7 plus 1 is 8. And again, you can type this whole thing, the square root of 7 times 7 plus 15 into the calculator to let it do the calculations for us. But if we did it by hand, 7 times 7 would be 49. 49 plus 15 is 64, and the square root of 64 is 8. So that tells us that p is equal to 7 is our solution that does work for this here. Any questions on any of this here? Any other questions on anything we've done so far today? All the rest of this here is the exact same thing. It's just more examples of it. I think it'd be better time spent, instead of doing the rest of these here, is letting y'all go on and work on the assignment. So if you do have questions, you can ask as you're working through those there. There is one last thing I do want to talk about, and that is questions number 45 and 46 from the homework. So here, I'm going to explain this here just a little bit because it can be somewhat confusing. For 45 and 46, determine which solution, if any, is an extraneous solution. So again, extraneous solutions are the ones that don't work, not the ones that do. So if we're looking at this here, for this problem, well, go back. Okay.